Moving on to the last section of 2.1, motion and speed notes, we're going to be talking about motion graphs and velocity. Okay, so motion graphs, um, we can describe the motion of an object by looking at the graph in a distance versus time graph. Okay, so constant speed is speed that does not change and is indicated by a straight line on a distance versus time graph. So if we look, each of these lines are straight. So each swimmer in this case is going at a constant speed. Same with this one, they're going at a constant speed, okay, because they have a straight line. Here, they go for a constant speed, and then their speed changes, and then it changes again, okay? We don't have any curved lines like what you would see maybe in geometry class if you've taken geometry. Sometimes we can have curved lines. That would mean that the speed is changing. So all of these in the examples that we're going over are going to be a constant speed because they have a straight line or a straight slope. Even though this one does change, it's not changing constantly like in a slope or in a curve. Okay, so the slope on a distant versus time graph is directly related to the speed, okay, because it's distance over time. Okay, and we just talked about how speed is distance divided by time. Okay, so the steeper the slope, the faster the speed. So if we look at this, between swimmer 1 and swimmer 2, the faster swimmer is swimmer 1, right? Because they have a steeper line than swimmer number 2. And if we look, it makes sense. In time of 50 seconds, the swimmer 1 got further away. They got 100 meters, whereas swimmer 2 only got about, about 50 meters away. Okay, so swimmer 1 was swimming faster. So the steeper the slope, the faster the speed. Okay, so how far did each swimmer go? And I kind of just went through this. Swimmer 1, they went 100 meters, and swimmer 2 went about 50 meters because it's right between 40 and 60. Okay, how long did it take swimmer 1 to go 80 meters? So if we look, swimmer 1 is the green line. Here's 80 meters. I'm going to drag my finger over until I hit my green line. Okay, so at this point here, now I'm going to drag my finger down to see what time. It was at 40 seconds. Okay, and then calculate the speed of each swimmer. Okay, so we're going to take the total distance that they traveled divided by the total time. So for this first swimmer, swimmer number 1, we're going to take 100 divided by 50, and we're going to get 2 meters per second. So I took distance divided by time, just like what we just practiced. Okay, for swimmer number 2, they went 50 meters in 50 seconds. So 50 divided by 50, we're going to get 1 meter per second for the swimmer number 2. Most of the time we experience changing speeds, so we can calculate average speed by taking the total distance divided by total time. Okay, so what did the green swimmer do? So let's look at this green swimmer. So the green swimmer started off swimming and they traveled 400 meters, right? And then they stayed at 400 meters for an additional 10 seconds, right? From 10 minutes to 20 minutes. They stayed. So for additional 10 minutes, they stayed at distance 400. So that means that they were stopped. Okay? And then after the 20-minute mark, they started swimming again and got all the way out to 1,200 meters. So they swam an additional 800 meters. Okay, so anytime we see a flat line in a distance versus time graph, it means that they have stopped. Okay, so anytime we see a flat horizontal line with a slope of 0, it means that the object has stopped. What was the average speed of the green swimmer? So remember, we're going to take total distance divided by time. So we want a total of 1,200 meters divided by our time of 30 minutes, and we should get 40 meters per minute. And then for number 3, did the green swimmers swim faster in the beginning or the end of the race? Okay, so remember, the steeper the line, the faster they're going. So if you look, this one is a bit more shallow or less steep than this part of the line. This line is much steeper. Okay, so they were basically trying to catch up to the other two after they had stopped. Okay, so it's going to be the end of the race because the line is steeper. Moving on to velocity. Velocity is the speed and given direction of an object. Okay, so it's very similar to speed, except that it has direction. Okay, so kind of like how we talked about distance and displacement. Distance just has a quantity, whereas displacement has both the quantity and the direction. Okay, so distance and direction for displacement. For speed, we just have the speed of the object. For velocity, we're going to have the speed and the direction that the object is moving. So for example, if I was describing a car going 24 kilometers per hour south, that would be a velocity. If I just said 24 kilometers per hour, that would be a speed. So because velocity depends on direction as well as speed, the velocity of an object can change even if the speed stays constant. Okay, so velocity can change because it's changing direction, even if the speed of the object is still the same. So for example, if a car is on cruise control, meaning that it's staying at a constant speed the whole time, but it takes a curve, and so it was going, let's say, north, and it takes a curve around, so now that the direction it's going is northwest, that would mean that the velocity changed even though the speed did not actually change.